Okay, hello. We're going to be doing instantaneous rate of change, which is very similar to average rate of change. The only difference is that it's a change at a distance and takes two numbers that are extremely close together to get the instantaneous rate of change at an instant. So let's move on. A change that takes place at an instant. You take two numbers extremely close together to find the change that takes place at an instant. Instantaneous rate of change is also the slope of the tangent. And the short form is right there. As you can see here, this is the instant that we're trying to figure out. So we're going to take two numbers extremely close together. Some people use 0.1, some people use 0.01, some people use 0.001, and so on and so forth. But we're going to be using plus 0.1. As you can see below, here's the formula. To find the instantaneous rate of change, take x and x plus 0.01 and then input it into the formula. So for the function, s of t equals negative t squared plus 6t plus 5, find the instantaneous rate of change when t equals 2. So we're going to take multiple numbers that are 0.01 either above or below 2. As you can see here, we have our final x1 and x2. It's 0.01 below 2 and 0.01 above 2. So let's start. If you unplug this into your calculator, you should get 13.0199. And there's our instantaneous rate of change when our x1 and x2 are 2 and 2.01. let's input our x1 and our x2 into the formula. As you can see here, we're going to plug these numbers into our calculator to get the result. And we're left with 2.01 meters per second is our answer there. Again, we're going to put x1 and x2 into our formula. And plug these into our formula. And our instantaneous rate of change is 2 meters per second. I'm just going to write a therefore statement. And there you go. Okay. So for the function s of t equals t squared, Find the instantaneous velocity when t equals 3. So they're looking for the instantaneous rate of change. As you can see here, we have our x1s and x2s. And so, let's get started. We'll start with A, which is t element of 3, 3.01. 'And there's our answer. It's 6.01 meters per second. Let's get started. .599. Actually, I made a mistake. .0599. As you can see here, we plugged x1 and x2 into the formula. And we also subbed x2 and x1 into the formula there to get f of 3 minus f of 2.99, 3 minus 2.99. We figured out f of 3. We figured out f of 3, which is 9, and we plugged that in there. And f of 2.99, which is inputted right there. And we subtracted these two, which got 0.01, which resulted in 0.01. Then we subtracted these two and got this number, 0.0599. And then we got our answer dividing it by 0.01. And we got 5.99 meters per second. On to the next question. So as you can see here, we have t element of 2.99, comma 3.01 is for our problem here, and it's probably going to give us the best answer that we can get. It's one of my favorites, is when it's numbers 0.01 below and above are my favorite problems because they give you more of an accurate answer. So if you're going to follow the formula and add 0.01 into a number that you choose, I strongly suggest subtracting and adding, and then having those two be your x1 and your x2s. Because it will give you a more accurate answer. Okay, our answer is 6 meters per second. And our instantaneous rate of change, 6 meters per second. There's our therefore statement. As you can see, I used the formula, and there's two. They're basically meaning the same thing. I plugged x1 and x2 into the formula. I found f of 3.01 and f of 2.99, and I inputted those in. I subtracted these two numbers to get 0.02. I subtracted these two numbers to get 0.12, and I divided them to get 6 meters per second. So this is just extra practice. For the function s of t equals 0.4t squared plus 5t, find the instantaneous rate of change at 1 second, 2 seconds, and 3 seconds. And I've set up your t element and your x1 of x2, and I have the answers right here. So thank you very much for watching, and I'll see you later.